All right, so theorem 30, 60, 90 triangle theorem. All right, so 30, 60, 90 is known as a special right triangle, okay? So special right triangles have specific rules that we need to follow. Hey, put your phones up. I know I didn't do it yesterday, but today's a good day, considering I already saw some people on them. So put them up. That's fine. You have a charger? Oh, I have it here. Whoops. Forgot. I had to take this for like a hospital visit, so I was like, oh, do I have this? Do I not have this? You know what I mean? Yeah. All right. So 30, 60, 90 triangle theorem. In 30, 60, 90 triangle, the length of the hypotenuse is twice the length of the shorter leg. The length of the longer leg is square root 3 times the length of the shorter leg. So the hypotenuse is 2 times the shorter leg. The longer leg is square root of 3 times the shorter leg. Now, how do we identify what the shorter leg is? All right, the shorter leg is always across from the 30-degree angle. Okay, so this is the short leg. This is our long leg, and this is our hypotenuse. Okay. Anybody still writing? Luis, are you still writing? Okay. Anybody else? Okay. So this is just a very basic first example. So if this is 60, this is 90, this has to be the 30-degree angle. Directly across from that, again, is our short leg. Which means that what I'm going to do for this hypotenuse is I'm going to go take 2 times 5, which gives me a total of 10. And for x, I'm going to have 5 just times the square root of 3. Questions on that one? Okay. So I am just going to, again, for example 2, we're going to find x and y. We're going straight across. So this means y is the short leg. So what does this mean for everything else? Well, 12 is going to be, remember, this is 2 times the short leg, and we're sending that equal to 12. So we need to identify what the short leg is. So here's the key. Everything's based off the short leg. So if you don't have the short leg, you need to find it. Okay? So we have a hypotenuse, and I know that's a hypotenuse because directly across from the 90-degree angle. So I'm just going to take this, divide by 2. So here I'm getting y is equal to 6. So 6 is our short leg. And then to get the long leg, I'm going to take that short leg, which is 6, and multiply it by the square root of 3. Questions? All right, anybody still writing? Okay. All right, let's move on to this next one. So again, the short leg here is x. But we are given the long leg. The long leg is the short leg times the square root of 3. So I'm going to take this equals x times the square root of 3. And I need to solve for x. Remember when we reviewed radicals? What was it, Monday, I think? Monday, Wednesday, sometime this week? This is going to have to be in radical form. Okay? So that means I'm going to take both sides and multiply it by the square root of 3. So this leaves me with x equals 6 over the square root of 3. But I need to rationalize. You guys remember that? Rationalize the denominator. You can't have a radical in the denominator, right? So I'm going to take this and multiply both by the square root of 3 over 3. This is going to be 6 square root 3 over, oops, sorry, it's supposed to be square root 3. Right. This is going to be square root of 9, which gives me 3. And then what's 6 divided by 3 right here? 2. So 2 square root 3. And this is actually my x. This is my short leg. Okay? So that means for that hypotenuse, I'm gonna have to multiply that by 2. So this will be 2 times 2 square root 3, which gives us 4 square root 3. Questions on that? All right, find the altitude of an equilateral triangle if the perimeter is 21. All right, so one thing that's going to help me here is if I draw a picture. I'm going to draw an equilateral triangle. Now we're saying if the perimeter is equal to 21, that means, remember this side, and this side are all congruent, right? So I'm going to take 21 divided by 3. So each side is equal to 7. So how does that help me out? Well, I'm just going to draw a bigger one right here. So if this is 7, this is 7, this is 7, right? And an altitude is a point that goes from the opposite vertex and hits perpendicular to the opposite side. Now, because this is an equilateral triangle, this altitude is not only perpendicular, it is also breaks this side and this side in half, leaving this side being 3.5. So it gives us a midpoint there. So I'm going to focus in just on this triangle. Now, if this is 90, and this is my short side, that means this is 30, okay? And here's my hypotenuse of 7. This altitude, so in this case, the altitude is the long side of a 30, 60, 90 triangle. Here's my short leg. Oh, also, I forgot to mention, this altitude bisects this angle. So if this was 60, it breaks into 30. Sorry about that. Forgot about that. And this means that we have the altitude is equal to 3.5 square root 3. Questions on that? Anything I can address in general? All right, let's move on to the next page. Flip it over. We got 4 more examples on the back. All right, so Delta Math example 1, find the length of the side x in simplest radical form with a rational denominator. All right, rational means that you can't have the square root at the bottom, okay? So in this case, if we take a look, we have our 30, 60, 90. This is our short side. That means x is our long side. What is x going to be here? Square root 2 times what? Yeah, very good. So I have square root of 2 times the square root of 3. Now this only multiplies into square root of 2 times 3, which is the square root of 6. So there's our x. Questions on this? All right, so find the length of side x in simplest radical form with a rational denominator. All right, so again, we are given, is this the long side or is this the short side or is this the hypotenuse? It's the hypotenuse. So remember, this is 2 times that short side. I divide both sides by 2. What's the short side equal? 3. Questions? All right, number 3. So here we're going to find the length of this short side. What are we given here, though? Is it the long side or the hypotenuse? It is the long side. Very good. So in this case, this is going to equal that short side x times the square root of 3. And this is where we have to divide both sides by the square root of 3. All right. So this leaves me with 7 square root x equals 7 square root 3. I need to rationalize, which means I'm multiplying by the square root of 3 over the square root of 3. So this ends up being 7 square root 3 over 3 times 3 is 9. Square root of 9 is 3. So this is our x value. How are we doing so far with that long side stuff? Any questions? All right. Example 4, the triangle below is equilateral. Find the length of side x in simplest radical form with a rational denominator. Okay, so in this case, this is actually believe it or not, guys, this is actually very similar to this, except we have a hypotenuse instead, okay? So if we take a look at this, one thing we know is this is an equilateral triangle, so all this is congruent, right? The other thing we know is that this is our 30-degree angle, making this our 60-degree angle. Okay. So what we have here is we have the short side of that triangle. And if you want to, you are always welcome to just kind of rewrite this if it helps. Oops, not there. Okay. So in this case, this is just going to be, remember, the short side times 2. So x is going to equal 2 times the square root of 2. And that's it. The hardest part about this is identifying what you have. Okay? Any questions? I would like your Delta math done before you leave today. You have plenty of time. Okay? Thoughts you're watching at home. Have a great day.